Hi, my name is Matt Dowling. I'm going to talk a little bit about an idea in chemistry called VSEPR theory or VSEPR theory. It's spelled VSEPR and stands for valence shell electron pair repulsion, which is sort of a fancy way of saying how do electrons interact with bonds. So it's pretty much about the shapes that molecules can be in and the angles between the bonds in those molecules. There's 11 different configurations for molecules, and a few of them show up in a couple different ways. So I'm going to start by defining a couple colors here. We're going to have yellow, and let's get blue, and let's get a red. So we have three colors, and we're going to call these C for central atom. So this will be like the one in the middle. And then we're going to call this E for electron pair. And then we're going to call this F for functional group. So functional group being something connected to the center atom. Let's see. So we'll start with the most basic one. This is the linear geometry. So it is, hold on, brush size. There we go. So we're going to have this one in the middle right here. And we're going to have two red ones on either side. So this is linear, or one version of linear. I'm only going to cover one version of linear, because they're all pretty much the same. But basically, these are bonded together like this. And it has a 180-degree bond angle, as would make sense for something linear, right? So a straight line is 180 degrees. This is straight line bonding, so it's 180 degrees, and this is called linear. The next one I want to talk about is trigonal planar. So this actually has three functional groups. And wait, gotta get my yellow. Got a central atom right here. So this is trigonal planar, and it has three functional groups and bond angle of 120 degrees. Both of these are flat, like can be displayed in 2 dimensions. So as you see them on the screen is how they would look in real life. Most of, no, one more. We got one more first. Okay. So then the next one is bent, which is what you see in water molecules. So this looks like this one right here. Looks like this. So we have two bonds, and these two electron clouds push down on the bonds and make them get much closer together. So it's usually about 109 degrees, and this is called bent. There is one other version of bent, but I'm not going to talk about that one, and this is usually seen in water. All of these, I mean, with the exception, actually just these two are displayed fully in a plane, whereas everything else requires 3 dimensions to actually visualize. So both of these electron pair groups are either into the page or out of the page, and that'll pretty much be the case with the rest of these. So really quick, we're going to go through. This is going to be tetrahedral, and its bond angle is 109 degrees because despite it having 4 functional groups, only 2 of them are in plane together, which means the other 2, just like in this example, the other 2 are out in the 3rd dimension somewhere. So it gives them a little bit of extra space to move around. There is also trigonal pyramidal. So we get 3 functional groups, and they bond to a central atom, like so. And then they also have 1 electron pair. So that is trigonal pyramidal. It has also a bond angle of about 109 degrees. A lot of things have pretty similar bond angles. 109 degrees is fairly standard. It's when there's 4 constituents, basically. There is then, so the first one we had 2, then we had 3, then all 3 of these had 4. We got 5 and 6 left to go, so we're going to do 5 next. So we have a central atom. Actually, I think I'm going to erase this stuff. Oops, that's not what I meant to do. Why is it doing that? Is that not the eraser tool? I thought it was. Well, what is just... Well, we're going to undo that. Why won't it erase? That is really strange. Okay, well, I guess I can just make a new file then. And sort of, why is it black? We're going to paint bucket it nice and white. There we go. Okay, so let us get into the 5s and 6s now. So the first 5 that I'm going to talk about is trigonal bipyramidal. So we just saw trigonal pyramidal. This is going to be like 2 pyramids. It's, if you can picture it in 3 dimensions, it's like 2 pyramids. So these are all in plane together with one another, and they are 120 degrees apart. And then there's one up here and one down here that are 90 degrees apart from the other 3, and 180 degrees apart from one another. And that sort of makes the pyramid. So these 3 are like the triangular base of a pyramid, and then this is like the height of 2 pyramids. So 1, 2, 3, 4, 5. And that's that one. We then have the most interestingly named one called seesaw. And it is almost identical, except it has 1 lone pair over here that sort of pushes the other ones away. So, but the bond angles are the same, 120 degrees between the 3 in the middle, 90 degrees between the ones that are up and down. And then there is a T-shape, which looks like this. It's just, each of these is kind of like knocking one more constituent off, or knocking one more functional group off. So this now has 1, 2, 3 functional groups and 2 lone pairs. Boop, boop. And as its name implies, it looks like a T. Each of these is 90 degrees away from one another. And then, so that's all the ones that have 5 constituents. So then, lastly, we have ones that have 6. So the first one is called octahedral because it makes an octahedron. It is an 8-sided 3-dimensional figure. So there's 4 in plane together, and then one up and one down. Boop, boop. I know these are not the best drawings in the whole world, but sort of get the idea. Everything here is 90 degrees apart from one another. We then have square, pyramid, so we have the same four in the plane, one up that makes the tip of the pyramid, and then a lone pair down below that sort of cements the idea of a pyramid. Whoops, that is not the right color. Just going to go over that like so. And I want my black back. Okay. And it goes like so. These are also all 90 degrees. And then there is one more. It is the square planar. And it is what you would expect it to be. It makes a square. They have the four functional groups in the plane, 90 degrees apart from one another, and two functional groups, or excuse me, two electron pairs, one on top and one down underneath. So it's like a flat piece of paper with some electrons sticking up and down. That pretty much concludes the basic ideas behind VSEPR theory. And I hope you learned something, and thank you very much for watching, and have a great day.